Particle analysis in pharmaceutical formulations by Raman microscopy. Cough syrups, liquid-filled capsules, infusions or injections. Those are typical liquid formulations used to administer pharmaceuticals. Especially for the latter two, quality standards are very high. Impurities like solid particles in the liquids must be detected and analyzed during quality control tests to avoid critical complications. In this video, we showcase the use of Raman microscopy to detect such particles. But both infrared and Raman microscopy are very suitable techniques to analyze particles, each with their individual strengths and weaknesses. While Raman can access the smallest of particles down to the nanometer range, it suffers from long measurement times and reliability in particle detection. And while infrared microscopy can't go lower than roughly 5 micrometers of particle size, it offers amazing measurement speeds and exceptional particle detection confidence. Accordingly, IR and Raman are complementary methods that work best in tandem. This video focuses on Raman microscopy, but if you want to learn more about IR, click the link in the description. Let's continue with our sample. This biopharmaceutical formulation was prepared on a gold-coated PVC filter by pipetting and filtrating it with a special sample holder. Then the filter is placed underneath Bruker's confocal Raman microscope, Centera 2. Depending on the visual conditions, the filter pores may interfere with the automatic particle recognition. However, by adjusting the brightness, the contrast is greatly enhanced. When we are satisfied with the visual contrast, we start the automated particle recognition app. Each cross displays a measurement spot and found particles that are color indicated. Next, we start the measurement with just one click. The Centera 2 will automatically move from one measurement spot to the next. Depending on particle load, this might take a while. Afterwards, the MPID particle identification app will classify the found and measured particles. Simply drag and drop the Raman imaging file into the app window and click Analyze. The results are in, and it seems that most of the particles originate from precipitated protein. But there is an unknown contamination present that needs further investigation. The scale on the right indicates how strongly the particles differ in their Raman properties. Among the particles, there is a fiber with an unknown Raman spectral signature, which we can identify with a quick library search. The fiber is revealed to be cellulose. Both the presence of protein precipitate and fibers are clear indicators of inappropriate production or storage conditions. But what about even smaller particles? By switching the Raman microscope to a larger magnification, we can analyze particles under 1 micrometer in size. This makes Raman microscopy a versatile tool for particle analysis. Click here to watch infrared microscopy doing the same job. Thank you for watching.